Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When an aryl alkyl ether is treated with excess HBr, or high, under heat, the CO bond that cleaves is the alkyl CO bond, not the aryl CO bond, because the aryl CO bond has partial double bond character, resonance stabilization, and is much stronger and harder to break under normal acidic conditions. The oxygen is protonated first, then the weaker alkyl CO bond undergoes nucleophilic attack by Br. Moving on to the next step. PHO CH to CH2O. With excess HBr and heat, the ether oxygen is protonated to give PHO plus H, CH to CH2O. Moving on to the next step. The alkyl CO bond, the bond between oxygen and the CH to CH2O group, is cleaved by Br acting as a nucleophile in an SN2 fashion or via protonation and displacement, giving phenol, PHO, and BrCH to CH2O initially. And for the final step. Since HBr is in excess, the O group of BrCH to CH2O is also converted BrCH to CH2O plus HBr BrCH to CH to Br plus H2O. The aryl CO bond is not cleaved under these conditions, no bromobenzene forms, so the phenol, PHO, remains intact. Final products, phenol, benzene ring O, plus BrCH to CH to Br, 1,2-dibromothane. Why other options fail? A. Requires electrophilic aromatic substitution at para position, which does not occur here under HBr heat conditions with no catalyst. B. Requires cleavage of the aryl CO bond, which is not favored. Also the CH to CH2O alcohol would be further brominated with excess HBr. D. Requires cleavage of aryl CO bond to give bromobenzene, which does not occur under these mild acid conditions. Therefore, the correct answer is C. Therefore, the correct answer is option C.